As we navigate through the early days of June 2026, the atmospheric regime governing the North American continent has undergone a violent and unprecedented reconfiguration. We are no longer dealing with the typical, somewhat predictable transitional weather patterns of early summer. Instead, the United States has just entered a highly anomalous meteorological phase characterized by extreme temperature whiplash, a hyperactive and shifting severe weather corridor, and a tropical theatre that is defying historical norms. The data emerging from our latest meteorological models, ensemble guidance, and oceanic indicators reveals a complex interplay of teleconnections that is setting the stage for a prolonged stretch of active, dangerous, and historically significant weather. This is not merely a week of isolated thunderstorms or a standard summer heatwave. The atmosphere is currently responding to a massive influx of energy from the Pacific Ocean, a rapidly intensifying El Niño baseline, and the dramatic collapse of a persistent blocking pattern. The result is a weather regime that meteorologists are closely monitoring because of its sheer volatility and its potential to reshape the summer forecast for the entire country. From the explosive severe weather outbreaks tearing through the northern plains and the Midwest, to a rare, powerful cold front pushing unprecedented chill deep into the southeast, and finally to the complex tropical developments brewing in the Gulf of Mexico and the eastern Pacific, every sector of the country is facing a unique and elevated threat. What makes this current phase so unprecedented is the speed and scale of the jet stream reconfiguration. We are witnessing the transition from a stagnant omega block to a highly amplified split-flow jet stream pattern, driven by one of the strongest Pacific jet extensions recorded for the month of June. This shift is not just changing where the rain falls, it is fundamentally altering the thermodynamic profile of the continent, creating a ring of fire precipitation pattern, unleashing a historic deluge to cure the Midwest drought, and establishing a shear shield that is simultaneously suppressing Atlantic hurricane development while fueling explosive cyclogenesis in the eastern Pacific. In this comprehensive analysis, we will break down the exact meteorological mechanics driving this unprecedented phase. We will examine the immediate multi-day severe weather outbreak threatening the plains and the Midwest, the bizarre temperature anomalies bringing fall-like chill to the southeast, the complex and evolving tropical threats in both the Atlantic and Pacific basins, and the long-range outlook that promises to keep the weather highly volatile well into July. Every forecast, every model run, and every teleconnection discussed here is based strictly on the latest observational data, deterministic model runs, and ensemble guidance available as we move through this critical early June period. To understand the chaotic weather unfolding across the United States today and into the foreseeable future, we must first look thousands of miles to the west, to the Pacific Ocean. The foundational driver of this new weather phase is the rapid intensification of El Niño. The Niño 3.4 index, a critical metric for monitoring equatorial Pacific sea surface temperatures, has surged and is now approaching the positive 1.0 threshold. This indicates that we are rapidly approaching moderate El Niño status, a development that has profound implications for the global and domestic atmospheric circulation. The sea surface temperature anomalies are exceptionally warm, hugging the coast of South America and extending far to the south of Hawaii. However, the true catalyst for the unprecedented jet stream configuration we're seeing today is not just the equatorial warming, but a massive marine heat wave that has established itself east of Japan and extended deep into the North Pacific Ocean. This immense pool of thermal energy is currently fueling Typhoon Genmi, a powerful system tracking east of Japan. While Typhoon Genmi is causing significant short-term impacts in Eastern Asia, its meteorological significance for North America lies in its movement. As the typhoon recurves and moves north and eastbound, it is acting as a massive atmospheric piston, driving what meteorologists are calling a Pacific jet extension. This Pacific jet extension is the key to understanding the current weather phase. As we move through the first and second weeks of June, we're observing 1, 2, 3, and even 4 distinct troughs lining up from Eastern Asia all the way into the Pacific Northwest. These troughs are linking up to form a continuous, highly amplified bridge of jet stream energy. This is not a typical June pattern. In fact, meteorological analysis indicates that this is one of the strongest Pacific jet extensions ever observed for the month of June. The thermodynamic implications of this jet extension are staggering. As this powerful current of upper-level energy pushes into the Pacific Northwest and dips into the northern plains, it is injecting massive amounts of instability into the middle of the country. The storm energy available to the atmosphere today and over the next several days is off the charts. We are observing convective available potential energy, CAPE values, reaching 3,000 to 4,000 joules per kilogram. To put this in perspective, these are extreme values that indicate a highly volatile atmosphere capable of producing violent, long-tracked supercells, massive hail, and destructive straight-line winds. This energy is billowing up across the plains, directly fueled by the deep moisture transport and the dynamic forcing provided by the Pacific jet extension. Furthermore, the positive Pacific meridional mode, PMM, which is closely tied to these warm eastern Pacific waters, is enhancing the subtropical jet stream across the southern United States. This enhanced subtropical jet is acting as a conveyor belt, pulling immense amounts of moisture-laden air over land, which is not only fueling severe thunderstorms, but also setting the stage for a highly active monsoon pattern and tropical moisture surges later in the month. For the past several weeks, the United States has been locked in an omega block weather pattern. This pattern is characterized by a stubborn high-pressure system parked over the southern plains, which created southwesterly flow across the Rockies, coupled with a deep, persistent dip in the jet stream along the east coast. This block was responsible for the dry conditions in the Midwest, the heat in the southern plains, and the relatively quiet severe weather season in areas that typically see spring outbreaks. However, as of today, this omega block is collapsing, and the resulting jet stream reconfiguration is triggering the unprecedented weather phase we're now entering. A major storm system is currently emerging from the Pacific Ocean, and it possesses enough kinetic energy to shatter the southern plains' high-pressure ridge. As this Pacific disturbance interacts with the remnants of the omega block, it is fundamentally altering the wind flow across the continent. We are transitioning from a blocked pattern to a highly progressive split flow pattern. This transition is being guided by a critical shift in the East Pacific Oscillation, EPO. Currently, the EPO is in a positive phase, which supports the deep troughs and organized severe weather we are seeing today and tomorrow. However, the data indicates that after this Wednesday, the EPO will remain positive through next weekend before slowly transitioning into a negative phase, a state it will hold until the middle of July. This shift to a negative EPO is the harbinger of the new summer regime. A negative EPO typically builds a massive high-pressure ridge over Alaska, the so-called Alaskan Ridge. Normally, a high ridge on one side of the continent forces a deep trough on the other. While we are not expecting Arctic cold air to flood the lower 48, this Alaskan ridge will have profound temperature and precipitation impacts. It will drive a massive heat dome into western Canada, the western United States, and eventually expand into the lower 48 and the Great Lakes. Simultaneously, it will lock the primary storm track across the Central Plains, the Midwest, the Great Lakes, and out through the Northeast. Concurrently, we are monitoring the North Atlantic Oscillation, NAO, and the Arctic Oscillation, AO. Unlike previous winter patterns where a negative NAO would cause the jet stream to buckle deeply into the southern United States, the NAO is slowly trending toward a neutral or slightly negative state. This neutral NAO combined with a neutral Arctic Oscillation means the jet stream will not buckle south. Instead, the high pressure in the west will dominate, and the storm track will remain anchored in the northern tier of the country. This creates a unique summer scenario. The western and southwestern US will experience expansive, intense heat, while the central and eastern US will experience a cooler, stormier summer pattern characterized by frequent cold fronts dipping through Canada and the Great Lakes. Furthermore, this reconfiguration is creating a distinct split in the jet stream. The northern jet will stay anchored across the Great Lakes and the northeast, driving the severe weather and cooler temperatures. Meanwhile, a high-pressure system currently in the Gulf of Mexico will eventually shift over Mexico and into the Pacific. As it moves, it will engage the subtropical jet stream, which will kick in from the southwest. This subtropical jet will act as a moisture tap, pulling tropical moisture from the eastern Pacific and the Gulf into the southern and eastern United States, ensuring that the summer months will be highly stormy and humid in these regions, even as the heat builds in the west. With the jet stream reconfiguring and the atmosphere loaded with extreme instability, the immediate threat for today, Tuesday, and extending through Thursday, is a widespread, multi-day severe weather outbreak that threatens the northern plains, the Midwest, and parts of the southeast. This is not an isolated event. It is a prolonged sequence of storm systems capable of producing damaging winds, giant hail, and significant tornadoes. Today, Tuesday, the atmosphere is highly volatile. We are currently tracking a level 2 out of 5 slight risk of severe weather across parts of the Dakotas and Nebraska, with a large marginal threat extending through the Texas Panhandle, New Mexico, and the southeast. The primary hazards today are damaging wind gusts and large to very large hail, with some storms capable of producing baseball to teacup-size hail. However, the most significant threat today lies in the northern plains, specifically north of Rapid City, South Dakota. In this area, the wind shear and instability are aligning perfectly to support discrete supercells. These isolated, rotating storms have the potential to produce a tornado, and given the extreme thermodynamic environment, we cannot rule out the possibility of a strong tornado this afternoon. As the day progresses into the evening, these supercells will likely upscale and merge into a line of thunderstorms. While the tornado threat will diminish as the storms become linear, the wind threat will intensify, with damaging gusts of 60 to 70 miles per hour possible as the line pushes through the Dakotas and into Minnesota. A critical flooding threat is also developing today across the Central Plains, specifically centered over Kansas and the Nebraska border. The storms developing in this region are exhibiting back-building characteristics. This means that while the storms are moving eastward, new storms are continuously forming on the western edge of the cluster, causing the overall complex to remain nearly stationary or move very slowly. This training effect, combined with the immense moisture available, creates a heightened risk for torrential downpours and localized severe flash flooding. Tomorrow, Wednesday, the severe weather threat does not dissipate. It merely shifts and evolves. The threat will continue across the upper Midwest and the central northern plains. We are monitoring the area near Mobridge, west of Aberdeen in South Dakota, for the potential of isolated discrete supercells during the afternoon hours. If these storms can maintain their discrete structure before upscaling, the tornado threat will remain elevated. However, the most likely scenario is rapid upscale growth, leading to a dominant damaging wind threat across South Dakota, North Dakota, and Minnesota during the mid to late evening hours. Additionally, the threat for giant hail and damaging winds will persist across the Central Plains. By Thursday, the axis of severe weather will shift slightly, focusing on the upper Midwest and the northern plains. Another slight risk is in place, where giant hail, damaging winds, and a couple of tornadoes remain on the table, particularly in the Dakotas and Minnesota. Meanwhile, the southern tier of the country will see a continuation of scattered showers and thunderstorms, driven by the enhanced subtropical jet and the moisture pooling in the Gulf of Mexico. Looking ahead to Friday and Saturday, the weather pattern becomes even more complex and potentially more dangerous for the Midwest. As the low-pressure system responsible for the plains' severe weather progresses eastward, it will interact with the returning southwesterly flow across the Ozarks and the Midwest. Friday features a very large, broad area for isolated to scattered severe weather. The exact organization of the storms is uncertain, but the thermodynamic environment will support large hail and damaging wind gusts. By Saturday, as the low pressure moves across the Great Lakes, it could open the door for additional severe storms in Indiana, Ohio, and Michigan, areas that have seen a glaring lack of severe weather over the past 30 to 40 days. Residents in these regions are urged to review their severe weather action plans, as the atmosphere is primed for a significant outbreak. Furthermore, meteorological data indicates that we are entering the peak corridor for Derecho season. Starting in mid-June and extending through the summer, the corridor from South Dakota down to central Kentucky, including Iowa, Missouri, Illinois, Indiana, and eastern Nebraska, is at the highest risk for these fast-moving, long-lived lines of storms. Derechos are capable of covering hundreds of miles in 12 to 24 hours, producing widespread, catastrophic damaging winds, large hail, and even embedded tornadoes. The current pattern shift is the first major indicator that this hyperactive severe weather season is officially beginning. While the severe weather threat dominates the headlines in the plains and the Midwest, the temperature pattern across the country is experiencing a level of whiplash that is virtually unheard of for early June. We are witnessing a battle between an expanding heat dome in the west and a rare, powerful cold front that is plunging the southeast into a brief but intense June chill. In the western United States and the desert southwest, the heat is already building and will continue to escalate through the weekend. Today, temperatures are soaring into the 80s across much of the nation, but the southwest is already seeing single and mid-triple-digit temperatures. As the week progresses, this heat dome will expand. By Friday and Saturday, 90s will be widespread across the eastern sections of the country, and by the weekend, we are looking at mid-90s up and down the entire eastern seaboard. This heat is a direct result of the upper-level high-pressure building over the region, and it will cause AC bills to skyrocket as the mugginess eventually returns to the southeast and the Ohio Valley by Friday night and Saturday. However, the most anomalous temperature event is occurring in the southeast, where a rare, powerful cold front is pushing through with unprecedented force for this time of year. Typically, cold fronts in June stall out or weaken significantly before reaching central Florida. This front, however, is maintaining its integrity and pushing all the way through the peninsula. As a result, the southeast is about to experience temperatures that feel more like late October than early June. Today and tomorrow, temperatures across the Carolinas, Georgia and Florida will plunge to 10 to 20 degrees below normal. In the upstate regions of South Carolina and western North Carolina, highs that should be in the mid-80s will struggle to reach the 60s. Greenville, South Carolina, for example, is forecast to see highs around 20 degrees below normal. As we move into Tuesday evening and Wednesday morning, the chill will intensify. The upstate will see temperatures dropping into the 50s, with Asheville potentially seeing lows in the upper 40s. In the higher elevations of the Appalachian Mountains, including areas like Banner Elk and Boone, temperatures will drop into the 40s. This rare June chill will bring a significant, albeit temporary, drop in humidity. Dew points, which are currently elevated, will plummet into the 30s and 40s across the Carolinas and Georgia. For those in the southeast, this means a brief respite from the oppressive summer mugginess, with dry, crisp air replacing the typical June humidity. Even in central Florida, the front's passage through Orlando will bring a noticeable drop in humidity, offering a refreshing break during the early part of the rainy season. This cool anomaly will last through Wednesday and Thursday, but the rebound will be swift. As the upper-level dip in the jet stream lifts and the ridge of high pressure slides back to the east, the wind flow will shift to the south and southwest. By this weekend, the cool air will be entirely scoured out, and the southeast will experience what is being forecast as the best weekend in a long time. High pressure will build over the region, limiting rain chances and allowing temperatures to soar back into the 80s and 90s. By next week, the mugginess will return with a vengeance. Dew points will climb back into the 60s and eventually the 70s, fueled by a steady stream of tropical moisture originating from the Gulf of Mexico. This return of the humidity will reignite the daily afternoon thunderstorm pattern across the southeast, locking the region into a hot, muggy and stormy summer regime. As the severe weather and temperature anomalies dominate the continental United States, the tropical basins are presenting a complex and highly divergent picture. The 2026 hurricane season is unfolding in a manner that highlights the profound influence of the developing Super El Niño, creating a shear shield that is suppressing Atlantic development while simultaneously fueling explosive storm formation in the eastern Pacific. Let us first address the Atlantic Basin and the Gulf of Mexico, where social media and long-range model runs have generated intense rumors of a potential hurricane threatening the United States. It is crucial to separate meteorological fact from model fiction. Currently, the Atlantic Main Development Region, MDR, which extends from the Lesser Antilles to the coast of Africa, is experiencing very cool sea surface temperatures. This coolness is a classic indicator of a strong El Niño, which enhances wind shear across the tropical Atlantic. Furthermore, the subtropical jet is currently pulling dry air and Saharan dust across the basin, creating an environment that is highly hostile to tropical cyclone formation. For the next 7 to 10 days, there is no imminent threat of tropical development in the Atlantic. However, as we look 8 to 15 days out, both the European, Euro, and the Global Forecast System, GFS, deterministic models, along with their respective ensembles, are showing a fascinating and potentially significant scenario. The Euro model is depicting a system that forms in the eastern Pacific, crosses Central America, and enters the Gulf of Mexico, where it strengthens and tracks toward the Florida Big Bend, Georgia, and the Carolinas. The GFS model shows a slightly different track, with a system forming south of Cuba, crossing the Western Gulf, and impacting the west coast of Florida before moving into the southeast. This is often referred to as a drought buster scenario, capable of dumping massive amounts of rain on the region. While it is far too early to forecast a specific landfall or even guarantee development, the ensemble support for this period of interest has grown significantly. Unlike previous long-range rumours that lacked ensemble backing, We are now seeing multiple members of the Euro and GFS ensembles indicating low-pressure development in the Gulf. The environment in the Gulf during this 10 to 15-day window is projected to feature low wind shear and very warm sea surface temperatures, which are favourable for development. The primary impediment will be dry air circulating off the North American continent. If a tropical wave can survive the crossing of Central America and avoid the dry air, the Gulf environment is primed for cyclogenesis. We are monitoring this period closely, but it remains a long-range signal that requires daily monitoring. Conversely, the Eastern Pacific is already highly active, driven by the extremely warm water temperatures and the enhanced subtropical jet associated with the positive Pacific meridional mode. The National Hurricane Center is currently tracking an invest area with a 90% chance of development within the next 48 hours. This system, which could become Tropical Storm Amanda, is forming in the Eastern Pacific and is expected to track west-northwestward, threatening the coast of Mexico. While it's expected to eventually encounter cooler waters and increased shear, causing it to weaken, the moisture associated with this system will be drawn inland, fueling the monsoonal flow into Mexico and the southwestern United States. Additionally, a second area of concern, Invest 90E, potential tropical storm Boris, has a 40% chance of development over the next 7 days. This system is forming further south, near Central America. If Boris develops, it has the potential to strengthen and could either track westward toward Mexico or curve back into the Gulf. The ensemble guidance suggests that while formation is likely, the system may struggle to maintain intensity due to the broader atmospheric flow. In the Atlantic, a tropical wave is currently moving through the Caribbean, but the strong El Niño-induced wind shear and the dry air from the Saharan dust are completely halting any development. This wave will only bring tropical moisture, posing no threat of cyclogenesis at this time. Looking beyond the immediate severe weather and the tropical developments, the long-range outlook for the remainder of June and into July indicates that the unprecedented weather phase is here to stay. The transition to the negative East Pacific Oscillation, EPO, and the establishment of the Alaskan Ridge will dictate the temperature and precipitation patterns for the rest of the summer. For the second week of June, the pattern will remain highly active. The Midwest, which has suffered from a gaping hole in rainfall due to the persistent Omega block, is finally going to receive significant relief. The progressive storm track moving across the northern plains and the Midwest will deliver several inches of rain to the region. Areas like Fargo, Sioux Falls, and Minneapolis will see beneficial, soaking rains, with Grand Forks potentially receiving close to 5 inches of rain between now and mid-June. This deluge will be crucial for agriculture and wildfire mitigation, but it will also bring the risk of flash flooding and severe thunderstorms, including the aforementioned Derecho threats. As we approach the Father's Day weekend, June 15th through the 22nd, the core of the heat will shift. The warmth will move away from the Midwest and extend out toward the desert Southwest and the southern plains. Meanwhile, the upper Midwest, the Ohio Valley, and the East will experience temperatures that are near normal, kept in check by the frequent passage of cold fronts and the cloud cover associated with the active storm track. Precipitation during this period will be hyperactive across the Mississippi Valley, the Midwest, and the Ohio Valley, while the Pacific Northwest and southern Florida will remain unusually dry. The final week of June, June 22nd through the 30th, will see the establishment of what meteorologists are calling the Ring of Fire pattern. In this regime, a broad area of dryness will settle across the central and southern plains and the southeast. Meanwhile, the moisture from the tropics in the East Pacific will be lifted northward, fueling a robust monsoon season in New Mexico, Colorado, and the Four Corners region. The storm cluster risk will shift back into the upper Midwest, where the collision of the hot, dry air from the south and the cooler air from the north will create a highly volatile environment for severe weather. Temperatures during this final week will begin to spread back toward the plains and the Midwest, and the humidity will increase significantly as the corn crop enters its maturing stage, creating a sultry, stormy environment. By the time we reach July, the transition will be complete. The massive heat dome driven by the Alaskan Ridge will build and eventually transition toward the central United States. The storm track will remain anchored in the northeast, meaning the Midwest and the plains will experience a hotter, more humid summer than initially anticipated, while the northeast will bear the brunt of the frequent heavy rainfall events. This pattern, locked in by the negative EPO and the neutral NAO, represents a complete departure from the quiet, blocked pattern of May, ensuring that the summer of 2026 will be remembered for its volatility, its extreme temperature swings, and its relentless severe weather outbreaks. Finally, as we analyse the complex fluid dynamics of the Earth's atmosphere, we must also look to the Sun, which is currently exhibiting signs of increased activity that could have secondary effects on our technological infrastructure. Over the past 24 hours, the Sun has produced a series of 4 solar flares, 3 of which occurred in rapid succession and approached the X-class threshold. X-class flares are the most intense category of solar eruptions, capable of causing planet-wide radio blackouts and long-lasting radiation storms. While these recent flares did not quite reach the X-class mark, their impulsive and quick nature is notable. Coronagraph imagery confirms that these flares were accompanied by coronal mass ejections, CMAs. Although these CMAs are not considered exceptionally strong in terms of their plasma field density, their successive arrival times mean they are hitting the Earth's magnetosphere in rapid succession. This cumulative impact can cause geomagnetic instability, potentially leading to enhanced auroral displays at higher latitudes and minor fluctuations in power grids and satellite communications. While space weather does not directly drive the severe thunderstorms or the jet stream reconfiguration we're discussing, the increased solar activity is a reminder that the Earth's environment is being bombarded by external energy from multiple sources. The combination of a highly active sun, a super El Niño, and a collapsing atmospheric block pattern creates a truly unique and complex environmental matrix. The weather pattern across America has undeniably entered a phase that defies typical early summer norms. The collision of the Pacific jet extension, the rapid intensification of El Niño, and the collapse of the Omega block have created a volatile, high-energy atmosphere. From the explosive supercells and back-building flood threats in the plains to the rare June chill plunging the southeast into the 40s, and the complex tropical developments in the Pacific and the Gulf, the meteorological landscape is shifting beneath our feet. This is not a time for complacency. The transition into the negative EPO and the establishment of the Alaskan ridge will lock in a pattern of extreme heat in the west and relentless, severe storm tracks in the central and eastern United States. The Midwest is finally receiving its long-awaited deluge, but it will come at the cost of severe weather and flooding risks. The tropical basins are playing a game of cat and mouse, with the Atlantic suppressed by shear and dust, while the eastern Pacific churns out systems that will fuel the summer monsoon and potentially cross into the Gulf later in the month. As we move through this critical period, it is imperative that everyone stays weather aware. Review your severe weather action plans, understand the specific threats in your region, whether it is tornadoes in the Dakotas, flash flooding in Kansas, or extreme heat in the Southwest, and monitor the daily updates. The models are in agreement that this active, dangerous, and unprecedented phase is just beginning. The atmosphere has been reset, and the summer of 2026 is officially underway. Stay safe, stay informed, and prepare for a highly active weather season.